All right, we'll just wait a couple more minutes and then we'll get started. Everybody like one?
Thank you. I just finished one from yesterday.
Oh, great, great, great. Now you can replenish it. Oh, boy. Audrey, could you ask Anshul to reach out to the IT people because of the really faded?
I did already.
Oh, dang.
Yeah,
Okay.
Anshul told me to.
Oh, okay. Okay, cool, cool.
Fix that.
Did they say anything at all yet or no?
Well, I did it like an hour ago.
Oh no, yeah, but usually they would like come by quick, but guess not.
Oh, Anshul wanted it to be like not during lecture time.
Oh, yeah,
so
yeah,
not
yeah.
like distract.
I see.
So you will hear back.
Totally fine. Yeah, yeah. Yeah. All right. Cool. Well, I guess we can go ahead and get started. Welcome, Tyler, to class. Today we're going to be going over expressions, data types, variables, inputs, and arrays. Lots of different things. Basically, the very, very intro into working with a programming language. So a couple of announcements. So lab 1 happens today for the other section. We had our lab yesterday. Were you at the lab yesterday? Yeah. Okay, great. And then discussion 1 was also yesterday, but only one person showed up. It's discouraging, but that's okay. For now, we're going to keep the discussion schedule and just encourage attendance. And we're going to probably be sending out a message to all of y'all to see what could help out for attendance. Like, what do you guys want to see in discussion so that it can incentivize y'all to come in. And then also, programming assignment 1 will be released later today. I think it's scheduled to release like around 2 p.m.-ish. So then you can start working on that very soon. And it'll be due next Monday. As for our whole like lab discussion meeting times, we're still waiting on one more student to see if they're okay with doing the switch. If they are, then I'll let y'all know by today or tomorrow morning at the latest. So that we can see whether we're going to be meeting tomorrow for a lab or a discussion. So if we do the switch, tomorrow would be a discussion, not a lab. Today still go to the regular discussion that we had planned. But starting tomorrow, maybe not, but we'll let y'all know very soon for if we merge everyone together. Okay, great. So a couple to-dos. So these are the same to-dos that we had at the very end of the lecture yesterday. So make sure to fill out the pre-course survey so that we can see, learn a little bit more about you all, and also get to hear what you want to see and like how you're feeling about the class. Make sure to also join EdSTEM, which is where everything is going to be at. Again, this is where we're going to see assignments, labs, discussion, some lecture activities even, lots of different things. And then lastly, Code Help. Code Help will be basically where you can be getting 24/7 assistance anytime you'd like using a large language model, but using a large language model that will not just give away the answer, rather give you step-by-step instruction on the material. The office hours, so right now, actually Anshul has his office hours right now from 12:30 to 1:30 at CSE 2109. CSE is the computer science building where y'all have your labs. And then my office hours are Mondays and Wednesdays from 10 a.m. to 11:30 a.m. So make sure to stop on by whenever you can, so you can ask for any help that you may have. This is all also on the course calendar. Okay. So asking questions during lecture. I mean, right now it's just you, Tyler. So you can ask however you'd like. If you're still nervous about it, like this is for when we have larger classrooms and such. But we do have a discussion post on EdSTEM. So if you were to open up EdSTEM and you see the discussion, there's something called Lecture 2 that's created by me. And I'll be having one of these for every lecture. And then you can ask your questions there as comments to the post. And then you can just like upvote questions and things like that. So that our TAs and tutors can be monitoring the actual discussion post to see if someone has like a question they don't want to raise their hand, something like that. That's totally fine. You can go ahead and ask it there. You could ask it anonymously as well, to see, to get your questions answered. But also, you can always ask questions directly during lecture. You don't have to use the EdStem. You can just raise your hand, as is like a traditional classroom environment. Sound good?
Yeah.
Also, since you're the only one here right now, if you need more time on a certain subject, we stay on it. If you think like, okay, I got it, and we can move on, then we can move on quickly.
All right.
Okay. Alrighty. So some big ideas for today. We're going to be covering hopefully a lot of this, hopefully all of it, but we're going to be covering a lot. So we're going to be covering first off expressions and the orders of operations of expressions. Something called data types. So different types of data that we can use in Python. Variables, you may have heard of variables like in algebra and things like that, so we'll be looking at that, getting some input from the user so we can actually communicate with the computer, and also type conversions and errors, and we'll get to that at the very end. So for the lecture participation form, make sure to click that participation form so you can start submitting your answers to questions, and this is also kind of a way to get attendance, but I wonder how else we can get attendance, Tyler's here. No one else? It is what it is. All right, cool. So make sure to open up the participation form so you can submit. All right. So today what we're going to be learning about, so writing code means you have to follow some very specific rules, okay? Grammar and punctuation in writing. We're going to learn some of these basic rules today. So basically, when you are writing in Python, Python has very specific words that are special, ways of displaying information. It's all special, and we're going to be learning basically most of those rules right now. Okay. So, and this is all when we write on like a Python file or a Python prompt. Okay. So I'm going to go ahead and open up EdStem now, so we can see what we mean. There's something called a Python prompt and a Python file. I'm going to go to my workspace, lecture 2. You all should also have access to the workspace already. You can just see the workspace as I'm working on it. And then if you want to look at these files later on, this workspace will be there for you to look at any time you need. Okay, so let's start off with files versus prompts. So there's these two different things. Let me make this a bit bigger so it's easier to read. All right, cool. So there's a thing called a file and a prompt. So remember last lecture where we had here this terminal, and here we would say, Python, read this file, where you're telling the system, I want you to read a Python file, then you give it the file name that it's going to run, right? So kind of like this, we have this file called fun with strings. So if we were to put Python space fun with strings.py, we can enter it, we don't get any errors or anything, and it'll just read it. But right now we don't have anything inside the file, which is fine. So that's why we don't see anything happening. But there's this other thing called a prompt. Okay? A prompt is basically living within just the terminal. So let me go back to the slides just so you can see. So there's these two different things. One is called a Python prompt and a Python file. Yesterday, what we were working with, and right now when we saw with fun with strings is a file. And you can write to a file, and then you could save a file. But you could also use this thing called a prompt. And the prompt, here, let me clear this. Also, this word clear, if you click clear, it'll just remove everything. So nice little thing for you. But if we want to use a Python prompt, what you could tell the system is, Python, I want you to start reading Python, but you don't give it a file name, you don't give it anything at all. You just say Python, and then you enter in. Ba-bam! We have entered into the Python prompt. Okay? Here is basically where you could be typing a bunch of different things, and this will not be saved. Okay? Think of this Python prompt to be kind of like a piece of scratch paper, where you can work on it, you can do a bunch of stuff with it, you can make some math calculations on it, you can work on it, but at the end of the day, you're just going to crumple up that paper and throw it away. Okay? So anything that you do inside this Python prompt only lives within the Python prompt. What do I mean by this? We can try out some things. So just like we said before, we're going to be looking at some rules, right? One of those rules could be, you could do math operations. So can anyone here tell me what 3 plus 5 is?
8.
Boom, 8, right? So here in this Python prompt, you could basically put some sort of math, you press enter, and it just gives you the answer, right? And the way that you do this with the prompt, you don't have to be clicking print. So remember how we had before, in front of, we would say like print, and then hello world? Something like that?
Yeah.
When you're working in the file, you would need that. But here, when you're working in the prompt, all you need to do is put whatever you'd like to see, and it'll immediately return to you what you were looking for. So right here, we have 5 plus 3, and it'll just give 8.
Is it like it runs like any Python code, or is it just like...
Yeah, that's a great question. Yeah, it runs any Python code whatsoever. So let's try that out. So we can also put here print hello world, right? Let's see what happens. Hello world, right? But if we were to put hello world, oh, we have this error, a syntax error. What's different between this line and this line that made us get this error?
There's no print.
There is no print, right? Let's try it with a print. Print, hello, world. This should work?
You need your quotation marks.
Ooh, all right. Let me put some quotation marks right there. Should that work?
In the middle, in the middle.
Okay. Where should I put it?
Outside of the words hello, outside of hello world.
Outside of hello world, something like that.
Yeah.
And something like this.
Yeah.
Ta-da, perfect, great. But let's see what would happen if we were to just put hello world, right? We also get this error because it doesn't know what this hello world is, but it does know what this is. Why does the system know what hello world is when it has quotations versus when it doesn't have quotations?
Because like, it's just like gibberish if it's not like with the quotation marks.
Yeah, so it could just be gibberish, right? The reason why it's gibberish, or like the reason why it can't understand it, it's kind of like what we were talking about yesterday about zeros and ones, right? How our Python code is basically gonna translate it to whatever the machine can understand, which is just zeros and ones. But part of those rules that we were talking about earlier is that you need to give it specific things. So hello world, yes, we understand what hello world means. However, the system, the Python system, will only know what hello world is if you tell it with these quotation marks. These quotation marks are what's called a string. Okay? These quotation marks, whenever you put things in between them, is something that what we call a string. A string is basically the data type of just words, right? Text, this kind of stuff. So, you put hello world, it'll show hello world. Why is it now showing single quotation marks? What happened? It's a little weird.
Is it like the default?
Is it the default? I guess you could say it's like the default. But basically with Python, another one of the rules for strings is that you can use either double quotation marks like that or single quotation marks. We can also do hello world like that. Enter, and we have hello world. So basically, if you want to use text in any way, you could use either the single or the double quotation marks. That make sense?
Yeah.
Right. So, let me go back here. So, all right, so. So now we have these things here, right, in our Python prompt. Let's say we want to do a bunch of math operations. So, first let's do, what's 27 plus 13?
40.
40, all right. What's 65 divided by 5?
13.
13, oh, yeah. Yeah. What is 765 for 3 times 1, 2, 3, 4, 5?
I don't know.
Oh man, me neither, yeah. That's a big one. That's a big old number, right? But, so we have all these things here. And where is this? This is all still in the Python prompt, right? None of this has been written into our file. But, that means that whenever we're done with this, right, it's kind of like a scratch paper. We're going to exit out. And now, all of this that we wrote before, all of this is basically going to be gone. Like we're not going to be able to see it anymore. So when we clear it, it's just gone, right? Because like a scratch paper, we crumpled it up and we threw it away. But what if we want to save all the same things that we were doing and we want to keep it for later on? That's when we use a Python file. This, like whenever we look right into a file and we tell the system to read the file, it's always going to read whatever the file has, and the file can be saved, right? The Python prompt cannot be saved. Because the Python prompt cannot be saved, typically, you're not going to write Facebook in the Python prompt because it'll just be gone. It will just be scrapped and thrown away. A lot of times the Python prompts are pretty good if you want to do something really quick, right? Like, I need a calculator and I don't want to go to calculator.com or whatever, and it's just right there. You can very quickly do something. Or if you have an idea of a Python program, like, is that going to work? But you don't need to make a whole entire file. You can just use a Python prompt really quickly to try something out, right? So let's try and save some of this stuff here in terms of the math operations we're doing. What did we say? We had like 3 plus 5. We had 27 plus 13. We had 65 divided by 5. And we also had like some crazy number times 1, 2, 3, 4, 5, right? So now that I have this here, let's see. Now that I have this here, let me clear this up again. What's going to happen when I do Python math operations? Now we're probably going to finally be able to see all of these things back to back to back without having to type it all out. And anytime we want to run it, we could run this file over and over and over again, and we're always going to get what we would like. So let's run it. Nothing happened. Oof, 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 oof. Nothing happened. Why would that be?
Oh, you didn't print it?
I didn't print it, right? So what we learned in the past is that we need to have something called print, right? Print is like you're telling the system, I want you to say something out loud, right? And you're going to say it out loud right here. But you need to tell it what to say out loud, right? What happens if I go like that? Will this work?
You need to put like the math operations inside of the print.
Inside of the print, yeah. So if we run it, we get like all this empty space, right? Nothing happened. But if we put this math operation inside, let's try that out. Boom. Let's just do one of them for now. Boom, we got 8. Fantastic. Now we can do the same thing with all this other information. Okay, we can print that. We can print that. And finally we can print that. Let's clear that up. And let's go to math operations.py. 8, 40, 13.0, and that number. Really big. But now, this is saved because it's in the Python file. Now the next time I want to run it, it's still there. It's still there. It's still there, right? And these files is where we're going to be able to write our programs and rerun them, and run them however many times we'd like, right? And it's all going to be saved in here. But if it were the Python prompt, again, that would not be saved whatsoever. That makes sense so far?
Yeah.
Great. So let's keep on going. And then, okay, just like math, right? Math has an order of operations. Does anyone remember what that order of operations is called?
It's like PEMDAS or something.
PEMDAS, exactly right. PEMDAS is parentheses, expressions. Then it's what is PEMDAS? Multiplication and division, right? Multiplication and division. Then A and S is addition and subtraction, right? PEMDAS. And there's an order of what takes highest precedence. So, just like math, math still exists inside Python. So, we can do some pretty complex things inside of Python. Right here. We can go ahead and delete all that. Okay, so we kind of covered this already. Some code examples of expressions, right? We had some math operations already. 2 plus 7 is 9. 5 minus 2 is 3. 10 times 4 is 40, right? And what we're going to be able to do now is talk about different ways of doing operations. Let's look at some operations right now. First, let's do parentheses, right? something very simple. Let's try out print 5 plus 7, right? Well, if we were to do print 5 plus 7, it's still 12. And with these parentheses, are we done? Not really, because these parentheses first, these parentheses only are really talking about the print, right? So what happens if we do this? Plus 5, now let's do times 2, right? So if we do this, what will be the answer?
19.
5 plus 7 times 2. 19. Why would it be 19 instead of 24?
The order of operations.
Yes, the order of operations says first we have to multiply 7 times 2, then we add 5. Let's try that out. Let's run it. 19. Fantastic. But I thought, darn it, what I wanted it to be was 24. Yeah, 24. So what you can do is use some nifty little parentheses right there. Let's run it again. 24. Because now, with the parentheses, we have to look inside of what's going on. Do that first, then we can do the multiplication. Right? We could also do something with exponents. Right? Exponents are when we raise something to the power of something else. Let's keep it like this, but now let's do 5 plus 7 to the power of 2. How can we do that? Well, Python has a way of doing it. Instead of doing 5 plus 7 and then having to do 5 plus 7, right? And then having to do that again, 5 plus 7. Instead of doing that 3 different times, or 2 different times, to do the exponential form, what we can do is something called multiply, multiply 2. This quick multiply, multiply, oops. Oh, I have one too many parentheses. I have my open and close parentheses right here. I have my open and close parentheses right here. And then there's an extra one. Python gets mad and says, whoa, you're not allowed to do that. So we have to delete it. Then we can try it out again. All right, 144. And the reason for that is 7 plus 5 is 12. And then 12 times 12 is 144. Yeah. Great. And then instead of doing it 2, 3, 4 times, you can just very easily just change one number here. And then we get 1,720. 144 times 12 is this number. Okay, great. Any questions so far?
No.
No? Great. All right. Now we can also, oh, yes. We have some other operations. Let's look at all of these. So we just looked at parentheses. We looked at the exponentiation, right? We also did some addition and subtraction. We did some multiplication. But now there's these other things, right? If multiply, multiply is going to be exponentiation, what is divide, divide? That's really weird. First, let's do like a regular division. Let's look at that here. So let's just divide. Let's do 12 divided by 3. What should this answer be?
4.
Let's check it out. 4, right? We get this 4. But what happens if we do 12 divided by 5? What happens?
You get like a float.
What's float? I don't even know what that is, right? We haven't covered that yet. We will very soon, right? So if you were to do 12 divided by 5, you get 2.4, right? With 2.4, that's great. We know what that is, but we're also seeing this little decimal. This decimal is what Tyler here said is a float, right? A float is basically a number, any number that we want, okay? Numbers, and a float will be a number with this decimal point. You could get some numbers without decimal points. Let's look at that here. We could do something divide, divide, right? If we do divide, divide, we just get 2. Why do we only get 2? Basically, this is what's called integer division, where you're going to be dividing something, but the answer that you're going to get, you don't want any decimal points with it. So anything after the decimal point just gets ignored. Okay? We're only looking at the left part of the decimal point.
Okay.
Because we want what is called an integer. What's an integer? We heard float and we heard integer. Floats and integers are basically both the same. They communicate very similar concepts. Both of them just talk about math, right? Numbers, right? But there's different types of numbers, right? As we've seen right now. One type of number is with a decimal point and another number is without a decimal point. Numbers without decimal points are integers. Numbers with decimal points are floats. Okay? So this divide is only going to be looking at anything on the left side. Right? So that's what is called integer division. Any questions so far?
No.
Nope. All right, great. So there's also this other thing that we want to look at. This is a little percent sign. What could the percent sign be? Let's try that out. What could it be? Well, this is called a modulus. Modulus. We're not gonna use it too often in this class, but it's pretty useful when we're looking at certain math operations that you want to make. Let's look at what it gives us here. It gives us 2, right? So why is it giving us 2? The reason for that is the modulus is only going to be looking at what is left over after the division. So think about long division. So we have 12, right? And it's being divided by 5, right?
Yeah.
So if we do 5 goes into 12, how many times? 2 times. We subtract the 10. We have 2 left over. This left over part, that is the modulus. Okay? So to make it a little bit more clear, what happens if we were to put 13, right? 13, we have 5. And we have 13. 5 goes into 13 how many times?
2.
2 times. We have a leftover of 3. The modulus should be 3. Let's run it. Oh, what happened? Oh, I didn't put math operations. Now we get 3. Okay? So this modulus is only going to get you the remainder of what's left when you're doing some long division. That make sense?
Yeah.
Yeah? Okay, great. I'm going to go ahead and erase that for now. Don't need that yet. Any questions so far?
No.
No. Awesome. All right, so that about does it for all the order of operations, the operands.
If you have like
Yeah,
2 operations that are on the same level, does it just go from like left to right?
let's try that out. So we know that which 2 operations are in the same level.
Oh, wait, never mind. That was a little bit of a silly question.
No silly questions. Don't ever say that. This is not a silly question. Let's try it out. So actually, let's just try it out here in the Python. What's this called? So this is a file. This is called a?
The terminal.
This is the terminal, yes. But when I write Python and nothing else in it, this is called a prompt. Remember, Python prompt. So let's try it on the Python prompt. So let's look at multiplication and division. Right? So let's do 5 times 5. Should be 25, right? Divided by 7, right? So 5 times 5 divided by 7 is 3.5714. Okay, great. So that means that 5 times 5 is 25. 25 divided by 7 is that number, right? But what would happen if we do this? 5 divided by 7. We would have a different number, right? We would get, oh, what's this? What's going on here? 5 times 5 divided by 7. Ooh. Yeah. Wait, that makes sense. Yes. Yeah, it's still the same number. But basically, it reads from left to right. If you have 5 times 5 divided by 7, it reads from left to right. Let's do some adding and subtracting to 4 plus 5 minus 5 plus 7, right? It just goes from left to right. But if we want to do, I guess a good way to do it with multiplication too, right? So 5 plus 7 times 2 minus 10. Something like that. What should the answer here be? First, we have to do the multiplication, of course, which is 7 times 2, which is 14. Then, do we go this way, or do we go this way first?
I think either way is fine, but
Either way is fine?
yeah.
Let's try that out. So, if we were to do nothing to it, we get 9. But, if we were to do 5 plus 7 times 2 minus 10, and let's put, oops. Let's do this like this, and this like this, right? This will give us something else, right? Because now we're dealing with parentheses. But basically, yes, anytime you read a math operation, if it's in the same order of operation, left to right, it should be just like good old regular vanilla math. Great. So, and also to remove ourselves from that Python prompt, I use a special word called exit. So once you say exit, it says, okay, I'm done with the Python prompt. I'm going to crumple up this paper and throw it away. Okay. All right, cool. Any questions so far?
No.
Nope. All right. So, what is going to be the result of the expression below? Answer now in your participation form.
Okay.
What could this be? 7 divided by 2. Tyler, why don't you go ahead and tell us?
I think it's 3.
You think it's 3? Why would that be?
I'm not really sure if it's 3 or 4 because I know it has to be like an integer, but I don't know if it goes up or down.
Okay. So, just like we had before, so yeah, we have this number 7, it's divided by 2. 2 goes into 7 how many times?
3.
3 times, right? And then we get 6. We have 1 left over. We could put a decimal, right? And then this goes down here as a 0. How many times did 2 go into 10?
5.
5, right? 10, and we're done with that. But you're saying you're not sure if it's going to be 3 or 4 because of, why is it not 3.5?
It has to be an integer.
Because it has to be an integer, right? Because of the integer division. But does it go up or down? It always goes down. Okay. So this will always end, like it doesn't matter if this was like 999999999. Anything that's to the right of this decimal point will just be forgotten.
Yeah.
It'll just be 3. Okay. We can also just try it out really fast. What does it look like? 7 divided by 2. Python. 7, 2, 3. Okay. Great. Let's go. Let's keep on going. Okay. What about this? 5 modulus 3. You can also look at. Actually, I'll let you think about it for a second, and I'll let you work it out. Would it be 2? Actually, what am I doing there? I'm just doing it here. 5 modulus 3. 5 modulus 3. 2. And it's because the remainder is 2. Right? So you just go ahead and do that. Let's continue on. We already did some of these order of operations. Basically, we know that 3 plus 4 times 5 is 23 because first you do 5 times 4 because it's in the higher order of operation, then you add 3 to be 23. Okay, cool. What will happen here? This is going to be kind of a tough one. Go ahead and think about it for a second. Remember your PEMDAS.
Can I just like plug it into the terminal?
Ooh. I guess you could. Yeah, honestly, why not? Yeah, yeah. That's why we have Python, right? Python's here to save the day in terms of these complicated math operations. But remember, what are we going to do here first?
The exponent.
The exponent. You're going to do 2 to the 4 first? Before anything else?
Yeah.
Well, the answer to that is not just yet.
The parentheses.
Parentheses first. P is for PEMDAS. PEMDAS for parentheses. So first you have to add 4 plus 1, right? And then you have this 5. Then we can go into exponents, which is 2 to the 4, which is 2 times 2 is 4, 8, 16. Right? Then we have 16 here. We have a 5 here. What is next?
The modulus.
Is it the modulus?
The modulus and the multiplication.
Which will it be first, modulus or multiplication?
Aren't they on like the same level?
Let's check that out. They are on the same level. Multiplication and modulus are both on the same level. Therefore, when we do this, 16 modulus 3 is the first thing that happens. What's 16 modulus 3? That'll be 16 modulus 3. I think that's what? 16.
Yeah.
16 modulus 3. 3 goes into this 5 times, right? 15. You have 1 left over, right? So that's 1. So all of this is 1. 1 times 5.
Yeah.
5. 3 minus 5.
-2.
-2. Did you run it on your
That's what I got.
-2? Awesome, great. So we see what the order of operations can do for us. And so we started to cover this a little bit already. Data types. So Python, whenever it's going to be talking with a computer, there are a couple of different data types. Today we're only going to focus on these 3, right? And these 3, there's 2 different ones for numbers and 1 for text. So we said that integers, int is for integers. Some integers, as we said before, they're numbers, they're whole numbers, right? They can be positive, they can be negative, but they're just whole numbers, no decimal spots whatsoever. But a float is called a float, is for floating point number. A floating point number is basically a number with decimal spots, right? So we have here 3.14, that's pi. We have 42.0. Even though it's 0.0, 42.0 is different from 42 in that one is a float and one is an int. They will have the same value of 42, but it's a different type, right? It's 2 different types. Then 9.18, it's got a decimal value. Now, data type for text, as we said before, they're called strings, okay? These strings, str, strings are basically anything inside of these single or double quotation marks, right? And this will always be just be text. Text only. These are not numbers. This is text. These are not numbers. This is text. These are not numbers. This is text. Okay? This 42 is different from this 42, which is different from this 42. All 3 are different 42s. Okay? Because strings are text. And Python is very strict about what is a string, and what is an integer, and what is a float, and how they can interact with each other. So, let's look at a little bit of that. What we can do is, let me exit out of this one, figure it out. What we can do is, with this, what we can do is find out what is the type of something by using the keyword type, right? So just like we said print, and when we say print, anything inside the print, I want you to say this out loud, right, to the terminal and tell me what it is. Type is only going to give you, instead of saying it out loud, it's going to give you what the type is. So let's look at type, and type will give you, let's say 42, as we were talking before. What type is this?
An integer.
An integer. What type is this?
Float.
A float. This class float. What type is this?
String.
A string. What type is this?
String.
Also a string, right? And as you can see, Python can tell the difference between all of these. And depending on what you're working with, is going to depend on how these different things can interact, right? So, what do we mean by this? Well, let's clear that all up right now. What we mean by this is that different data types can do different things. And also, the data type is very important in terms of what is going to be outputted into the system. Let's look at these math operations, right, that we had before. Print, as we had before, 5 plus 7. This will print out. What will this print out?
12.
12. So now, what if we wanted to put it inside as a string? Remember, 5 plus 7 is not the same as 5 plus 7 inside of a string. And here, it should be 12, right?
It'll print out like 5 plus 7.
Let's try that out. Oh! What happened here?
You didn't put like the...
That's right. I forgot that. It's going to print out 5 plus 7, right? Because when it's looking at this string, Python says 5 plus 7 inside of a string is not the same as actually doing 5 plus 7. Right here, it says whatever this is, I'm just going to take this as text and not do any math operations on it because I can't really do many math operations on strings. What's all plus 7? You can't do that, right?
Yeah.
It's kind of hard to do that in general because one is a string and the other is an actual math operation. But what if I'm wrong? Let's try this out. What happens if we do 5 plus 7? What will happen here?
I think it'll give you an error.
Why is that? It has a 5, and whatever 5 is, just add 7 to that string.
But they're like different types.
But could it be 57? Like it'll get the 5 and it says this is a string, and I'm not going to change anything with the string. But outside of that string, I'm seeing a plus. I can work with pluses outside of strings. Let me add this 5 to this 7. Is it going to be 57? Or is it going to be 12? Or are we going to get an error?
I think an error.
Let's try that out. Whoops. We get an error. And the reason for that is, like I said before, Python is going to say, this is a string, and I know what strings are. This is an integer. I know what integers are. But strings and integers,
Yeah.
they can't mix up. Okay? They can't mix up whatsoever. Because it's the same thing as saying this. Tyler, what's Tyler plus 7? Right? I don't know. Because Python's going to say, I can't do that. That's not really math. Right? Because one's a string and one's an integer. What about strings and floats?
I think you'll get like a similar error.
Similar error? Let's try that out. Math operations. Oof. Similar error. You cannot concatenate strings, not floats, to strings. Right? This is not a float. And this is not a string. But, let's do 7.0 plus 7.0. What will happen here?
It'll give you 14.
14. 14.0 because it's a float and a float, right? But what about this? Am I getting an error?
I don't know.
I don't know. Let's take a wild guess. Do you think this will be 14? Or do you think we're going to get an error?
Probably an error.
Probably an error. And why is that?
They're different types.
Because they're different types. Let's try that out. Let's run it. Oh, 14! Still, right? Turns out in Python, Python can differentiate, just like we were talking about before, where there's two different data types for the same thing of numbers. Python knows that that floats are numbers. And integers are also numbers. So Python knows that even though they're two different types, one with a decimal point, one without a decimal point, it'll say, I know that both of these things are still numbers though. And because they're both still numbers, I can still do some math operations on them. Okay?
Okay.
So you can do that kind of stuff. All right, so now we know that this can work even though they're two different types. But again, they're two different types because they're both numbers, right?
Yeah.
So What is this data type?
Float.
Is this a float? So 5 divided by 2? 5 divided by 2 would be, let's try that out.
Are the quotation marks counted?
Ooh, I don't know. First, let's try 5 divided by 2. It should be 2.5, right? But if we do the type, 5 divided by 2, we get the float. But just like you said, we have to make sure we look at everything. There's quotation marks here. So,
String.
let's try that out. It is a string, right? These quotation marks is telling Python, this is a string, no matter what, okay? Therefore, that is what you're going to be getting. This is actually a string. Okay? Great. So, data type for storing text strings. Yeah. So, strings, we've been talking about a little bit, right? Strings are text. And you can do a lot of different things with text, right? This is the data type that just stores text. Strings can be surrounded by either single or double quotes. We talked about that before, right? Either one of those. And strings can also be concatenated together using the plus operator, okay? So Python knows I can't add Tyler plus 7. That doesn't really make any sense because one's a string and one is a float or an integer. But what would happen if I were to do the following? Let's actually go to fun with strings now, because now we're working with strings here. Let's try to print out Ismael, right? This will just print out Ismael first. Python fun with strings. This is Ismael. But I want to add my last name, all right? What's my last name?
Molina.
No, it is Villegas Molina. Close to. In Latin American cultures, you have two last names. One is paternal and one's maternal. And so we have Villegas Molina here, right? So what happens if I try to add my first name and my last name? Am I going to get an error?
No.
Why is that?
It'll like add the two strings together.
Add the two strings together. Let's see what that looks like. Boom! With Ismael, Villegas Molina, right? Because Python knows that I can't really add a string with an integer or a string with a float. That doesn't really make sense to me. But I know that if I can get one string and I got another string, I just put them together, right? That's adding. That's what we call string concatenation. So anytime you add a string with a string, you are allowed to do that. Okay? But we have this like weird thing happening here where the L and the V don't really have a space. Why is that?
You have to put like an extra space in one of the quotation marks.
Ooh, let's put it right here. Let's try that.
Next to the V or the L.
Oof, okay. Next to the V or the L. I'll put it right here.
On the other side.
Ah, okay. Right here.
In the quotation marks.
Okay, in the quotation marks. In here?
Yeah.
Let's try that. Boom. Great. Thank you. Because when you're adding strings, it's not going to implicitly say, oh, I know that this is the first name, and I know this is the last name. I'll just add a space for them, right? It's not going to do that. It's going to do exactly what you tell it to do. So if you don't have that space, it's not going to have that space here. But if you do have that space extra, it will have that space, okay? Something that's a little cool, a little funky too, is that what if I want to say Ismael 5 different times, right? I can do this. Ismael. Man, I don't think I've ever written my name this many times before. 1, 2, 3, 4, 5. Man, that's not like Ismael. But I want to do it 20 times. Ah, jeez. Instead of doing it this and then copy pasting and trying to make it do it 20 times, what's really cool is that strings cannot add to other like integers and stuff. But what is the concept of multiplication? Multiplication, so let's say 3 times 3.
Yeah.
3 times 3 is basically 3 plus 3 plus 3, right? So Python's going to do the same thing here. Where if you have Ismael times 3, is going to be like Ismael plus Ismael plus Ismael. We got it 3 times. But now I want it 20 times. You run it like that. Boom. It's a lot of Ismael, right? So now we can see that strings can interact with integers if and only if it ends up being like just another concatenation, right? Because what if we try to divide Ismael by, let's say, 3 or 2? What's going to happen here? So if we know that multiplication is just adding a bunch of stuff, division is not the same thing as just subtracting a bunch of stuff. Division is its own thing, right? And you can divide using long division, right? How many times does 3 go into 16? 5 times, and you have a remainder of 1. Then you could add a 0, put it down, and keep on doing more math, right? But what is Ismael divided by 2? How many times does 2 go into Ismael? I don't know. That doesn't make sense, right? So let's try that out. And we get this error. Because it says you can't do this division between a string and an integer, right? So if you think about it, if you break down the math down to its simplest form, right? Just like multiplication to its simplest form is just adding things that many times.
Yeah.
3 times 3 is 3 plus 3 plus 3. But division is not the same. So you don't just subtract stuff. You actually have to do something like this, long division. 2 goes into Ismael, and we don't know. They're 2 different things, right? So we can't do that. You'd think that maybe it'd go to like in between, right? And give you ISM or something like that, but no, right? Because it's not just going to divide Ismael by 2. Where's the midpoint of 2, or where's like the divide by 10? You can't really do that, right? So, any questions so far on these data types? No. Okay, great. All right, so what happens here? What's the result of the following statement? CSE 8A is plus so times 3 plus much fun.
Option D.
Option D. Why is that?
Because like the middle part results in like 3 so's.
3 so's. So.
Or actually, I think it's C. Because there's a space I didn't see.
Aha! There's a space after this O. Because of that, it will have the SO space, then have much fun. Great. Yeah. A little bit trick question there that you caught. Way to go, Tyler. All right. So now we can work with something called variables. So in Python, we can remember things that we were working with before using something called a variable. Variables are basically used to store information for later on. Okay? Let's look at that over here. Here's like something about radius equals 10, but we can work with other stuff here. Let's go over to math operations now. And as we were saying before, we could obviously always print stuff, right? 5 plus 7. What happens when we do this? What's going to be the answer?
12.
Whoops. It's going to be 12, right? But we can also store that 12 to use for later, right? And the way we do that is with something called variables. And a variable can be, so let's call this a result, right? 5 plus 7 is going to result into something, right? 5 plus 7 is 12. But we want to use this operation and store it for later, right? And the way we do that is with this equal sign, okay? And we're going to say result, this name that we're giving, result, is going to be equal to whatever's on the right side of this, right? And right now, what's on the right side is 12.
Yeah.
So what's going to happen when I run this? I'm going to get 12, right? 1, 2, 3.
It won't print it, but...
Ooh, it's not printing, right? So how do we do that?
Just write like print result.
Print result. Like this?
Or like with the result in parentheses.
Result in parentheses. 'Result. Let's try that. 'Result. 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 Boom, 12, right? So basically, these variables can hold information for us so that we can use later on, right? So we can do something like this. This is called result 1. But let's say I want another thing, right? Result 2 is equal to 7 times 2, right? What's going to get printed here? Result 1 or result 2 when I print out result?
Neither.
Neither. What's going to get printed then?
An error.
An error. But I had result. Remember when I ran this, right? And this was under result. Shouldn't this be printing 12 still?
But you like got rid of result.
I got rid of result. Let's try that out. Aha! Yes. And the reason for that is because whenever we update our file and we save it, it's not going to remember all the other times that math operations file existed. It's only going to read from top to bottom right from the start. Okay. So in this case, results doesn't really exist. Result underscore 1 does exist, and result underscore 2 also exists. So we can do result underscore 1. That's 12. Result underscore 2. That's 14. Can we do this?
Yeah.
What's going to get printed?
14 plus 12.
14 plus 12. Is it going to be 14 plus 12 or the string 14 plus 12?
Like 26.
Going to print out 26. Oop. Forgot that. 26. What if I do this? Is it going to be 26 or is it going to be the string of 26?
It'll be like the string that says result 2 plus result 1.
Oh. That's exactly right. Because again, strings will only be a string. Right? This is the new string that we're looking at. All right, so now we can save some stuff and use it for later using variables. Can you do the same thing with a string? My string is equal to is my. Can we do that?
Yeah.
What's going to get printed out here?
Just my add.
Oof, it is. Can I do this?
Yeah.
What's going to get printed out now?
It'll print your name over and over.
How many times?
12.
12 times. Let's try that out. Boom. It's my 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. Great. So, basically, these variables, we're going to be able to get anything that we want, save it into something, and store it for later. What if I want to, have my numbers. What if I do this? Would this work?
No.
Why not?
You got rid of your variables.
Oh, how about this? Will that work?
No.
Why not?
It's the first line's like an error.
An error. Is it an error? Why not? What is going on here? Why can I not do this? Because Python, whenever you're going to be making a variable, you need to start off with a letter. You can't be starting off with a number, right? Or is it? What if I do 12a? Will this work?
No.
Oof, not working. What about this?
That should work. If you change the print.
Oh, thank you for catching that. A12. Will this work?
Yeah.
12. Great. And the reason for that, or what if we do A1? Is it still going to be 12?
Yeah.
That's right. Because this variable name, you can name it whatever you want. You can call this Tyler. Right? Tyler, if you run it, 12. Right? This name is basically anything that you want to call it. Likely what you want to do though is so that you remember, because this is just like 2 lines of code. let's assume that you're a software engineer and you're writing like thousands of lines of code. You're going to want to remember what you were doing before. So Tyler's probably not a good variable name, right?
Yeah.
We want to be mindful about the variable names that we're working with. So if we're working with like, I don't know, rent, right? And we're trying to make sure that we remember what our rent was. We were not going to call it Tyler, right?
Yeah.
We can call it rent though, right? Rent. And then this rent later on, we're going to be able to remember, rent's $12, man, if only, right? but that's what you can do. So these variables, you can call them whatever you want, as long as they start off with a letter, okay? So the letters that we're working with, the variables that we're working with, as we were talking about before, there's these things called, there's the difference between the file and down here, right, in this terminal. So the code below is written in a file named areaofcircle.py, right? So areaofcircle.py is a file. We have radius, which is equal to 10, and we have an area, 3.14 times the radius, which is the formula for calculating the area of a circle. And you can just print out the area, right? And this will show that the code inside of this variable, right? The variable inside of this file, radius and area, it'll still be able to print out. That's what we were doing before. But remember what we talked about in terms of files and the prompt, right? The file, you'll be able to remember all these things and keep it forever, right? And then no matter how many times you run it, you're going to have that. You're going to have radius and area there, so you can use it over and over again in your files. But with your prompt, what was prompt again? Prompt is going to be like this scratch paper.
Yeah.
That once you finish doing whatever you got to do, you're going to throw it. You're going to like crumple it up and throw it away. So while you're doing your scratch paper, right? You can have radius is equal to 10. That's great. Area is equal to this. That's great. You print out the area, and you get the area 314.0. That's the same thing, right? But let's try this out over here, right? So now we have radius is equal to 10. We have area is equal to the radius times, not radius times 2 times 2. What is it? Here we go. 3.14 times the radius, right? Then we can print out the area. So when we do this, we're going to get our 314.0. But if we were to do it inside here, right, we have our radius, again, of 10. We have our area being 3.14 times the radius. We can print out that area with 314. Again, same answer as we had before. But if we were to exit out of this Python prompt, we crumpled up the paper and we threw it away, right? So the next time you open up a different Python prompt and you do the area again, it's going to say, I don't know what area is, right? I've never seen this before in my life, because you got it, you crumpled it up, and you threw it away in the prompt. But if we were to just do Python math operations, area is still existing. Because again, this got saved into a file versus a prompt. A prompt will just crumple it up and throw it away. Does that make sense?
Yeah.
Any questions so far?
No.
Awesome. Great. Okay. Yep, we did that. All right, so the demo summary. Yeah, so basically what we're talking about this whole time. In a Python prompt, you can type statements into the Python prompt. Python will evaluate these statements and show you the result. And it'll show you what is printed by the statement. And these two are not the same. Statements typed into the prompt cannot be saved. You will not be saving this information.
Yeah.
You're going to be crumpling it up and throwing it away. With a file, Python statements can be placed into a file, and files can be saved. So you can use it for later on, and you can keep it for as long as you like. And you can run all of your statements in a Python file, and it'll execute them in order from top to bottom, as we were talking about before. And you're only going to see what is printed. You will not see any of the value of the statements, right? So when we were doing the prompt, right, we were just doing an expression, it would just give you the answer, right? Excuse me, but if we were to do that in the file, unless we say print and say this out loud, it's not going to tell us, right? We can just see it really fast again. One last time. So when we do the prompt here, if we do 10 times 3.14, it's actually going to tell us 3.14, right? But if we were to do it here, 3.14, let me remove all that, 3.14 times 10, and we were to run Python math operations, it's not going to tell us anything. Unless we say print, right? Unless you put something inside that print statement, unless you do that, it's not going to say it out loud. And you're not going to see it in your terminal. Though it exists inside here. It exists, but it's not going to be saved anywhere, right?
Yeah.
Because you don't have a variable. Any questions so far?
No.
Awesome. Let's keep on going. So what's going to happen with this? What's the balance of value after these statements are executed?
700.
Balance is 1,000 first. Then we have spent, we go to 300. Then balance is going to be equal to balance minus spent. Then you get your balance, which is, in this case, 700. Why is that?
1,000 minus 300.
1,000 minus 300. But shouldn't balance still be 100? Oh, you know, 1,000?
Well, it's like replacing the value when you say it equals something else.
Right. Because when we're talking about variables, remember, anything that's on the right of this equal sign is just going to get whatever that is, put that into here. This used to have something else, right?
Yeah.
1,000. And I looked at it here before we put it in here. So start off with 1,000 minus the 300, and then whatever that was, 700, is going to place it into this again. So now anytime you use balance, the balance got updated into 700. Okay, great. But what if we want to start talking with our user, right? So all this has been great, right? That we've been doing a bunch of math stuff. But one of the key things about computer science is that when you're with a program, right, you are actually interacting with the computer in some way, right? So whenever you go to Google or Bing or Yahoo, whatever you like, right, and you go and search something, you, the person, the user, has to go in and type search something. The system's not going to know what you want automatically. You have to tell it what you want.
Yeah.
Same thing with this, with input. So let's look over here into our lecture again. Let's go to funny strings. So before, we would always say print, you know, hello world, right? And we would Python hello strings. This would tell us hello world. And I'm going to say, I want to say hello to me. Hello Ismael. Ismael. Great. I run the program and it's going to say hello Ismael. Great. I love that. It's my name. It's saying hi to me. But Tyler, if you were to come and get this file, just absolutely just grab it and run it right away without thinking about it, what's it going to tell you?
Hello, Ismael.
It's going to tell you hello Ismael. And you're like, that's not me.
Yeah.
I am not Ismael. Who are you talking to, right? The way that we can do this is that this computer can start to like interact with their user with something called input, right? So input is something, it's literally what we were talking about in the last class, right? Input is something that you give to the system, something that you give to something, a program, and it does something with it and it gives something back to you. What we can do is we can have input, what is your name, right? When we have this input, what is your name? The system is going to be asking you to give it some sort of response. And it's not going to keep on going until you give it that response. It's going to wait until you give it some sort of response. Let's see what happens here when we run it. What is your name? And now, instead of just giving me that user Sahara all over again, it's going to wait. This program has not finished yet. Because it's still waiting for you to say something. What is your name? You, what is your name?
Tyler.
Tyler. Let's say Tyler. Boom. Great. Tyler. But now it's not really saying anything, right? It's not saying anything because, why is that?
You didn't tell it to do anything with it.
We didn't tell it to do anything with your name, right? So, what if we were to print this? what will happen here?
It would like throw an error.
Why is that? It didn't throw an error yet.
Or after you type in whatever you got type.
Let's type in someone in the back. Xiao Hui. What is your name? Your name is Xiao Hui. Oh! Error. What happened here? Tyler. What happened?
It doesn't like understand what Tyler is.
Yeah, that's tough. yeah. But well, it doesn't understand what Tyler is. But why is that? Because Tyler never existed up until this point, right? Oh man, this is gonna really. So the name Tyler, this thing called Tyler. Tyler, it didn't understand what Tyler was, right? But just like we were talking about with variables before, we can now. What if we do this? Tyler is equal to the input, and we print out Tyler. Let's clear all this up. What is your name? Your name is Xiao Hui. What will get printed when I run this?
Choppy.
Xiao Hui. Hi, Xiao Hui. How's it going? So the reason for that is because Tyler, even though we know Tyler, Tyler's great. He's right here. Fantastic guy, right? But Tyler in the system is a variable name. So whatever you put into this system, in the input, we put Xiao Hui. Xiao Hui gets stored into this variable name called Tyler. And then when we print out this variable name called Tyler, then we get the name of whatever was inputted here. Of what is your name? In this case, it was Xiao Hui. So as I was saying before, if you're writing like 1,000 lines of code, Tyler's probably not a good name to give this variable, right? Because at the end of the day, what is your name? What does that have to do with Tyler, really?
Yeah.
So what can we name this instead?
Name.
Name. It's a good name. Okay. So what is your name? Let's clear this all up. Through from the strings. What is your name? Let's go with Audrey this time. What's gonna happen? Audria! It prints out Audria, right? But this looks a little weird, right? What is your name? Question mark Audria? It's like too condensed. I don't have room to breathe. So what we can do is, when you're doing your input, you can also put a little space back here, right? When you put the little space back there, it's gonna print out that little space. So the next time you're asking for something, what is your name? Feels much better. Feels like something that we have worked with before. Who's back there? Jackie's back there. Hi, Jackie. It's my wife. And now, we can print out Jackie. Jackie's right here, right? But now it's just saying, Jackie, like the computer's saying, what's your name?
Tyler.
Tyler. That's all it's saying.
Yeah.
Kind of rude, isn't it? It didn't even say hi. So let's try to make this system say hi to us, right? Hi, name. Let's try that out. What's your name? Let's go with Tyler. Oh! Hi is not defined, right? What's wrong here?
You need like quotation marks around hi.
Ah, yes. You do need quotation marks around hi. So let's try this. Hi. Let's run this again. Let's go with Tyler. Hi, Tyler. Or hey, Tyler. Right?
Yeah.
How can we fix this so that it doesn't have everything squished together?
Put like a space right after the I.
Space right after the I. Let's try that out. What's your name? Tyler. Hi, Tyler. Great. Now you're talking to this computer, man. This is great. So basically this input thing is going to help you talk with your user, right? And whenever you're talking to your user, it becomes a much more dynamic program. Because now that system isn't always going to say, hi, Tyler, hi, Tyler, hi, Tyler, hi, Tyler, hi, Tyler. It's going to say, hi, Xiao Hui. Hi, Audrey. Hi, Jackie. Hi, Ismail. And for you, it's going to say, hi, Tyler. Like whatever you type into the system, that's what it's going to give you, right? And it makes our system much more dynamic in that like it'll be able to interact with a lot of different people rather than just putting one name and one name only, right? Does that make sense?
Yeah.
Right? So yeah, getting the input from the user is a very powerful tool. Very, very powerful tool. All right, so we have that, hello and name, right? How much time do we have left? Oh, we have 4 minutes left. All right, so I don't have much time to go over this, but basically, there's a thing called type conversion. So we were learning about types earlier, right? We're learning about what are the different types that we have in Python so far?
String.
A string,
Integer.
float, and an integer, right? And we know that whenever we're working over here with our math operations, right? If we do 3 plus 5, right? That's going to be Python math operations. It's going to be 8. And we know it's going to be 8, right? But if we were to do this, we're going to get some sort of error, right? Because the string of 3 cannot be added with 5. But there's this thing called type conversions. And we're going to say, we're going to get whatever this is. Let's say we want to convert this 3 string, right? We want to convert this 3 string to not be a string anymore. We're going to convert it into, you want to do a float or do you want to do an integer?
Integer.
Oh, dealer's choice, great, great choice. So, int, back in the slides here, when we first showed what these different types were, int is integer. So if you want to do a type conversion, right, we're going to say this 3, we want to make it something else. Instead of a 3, we're going to make it an integer. We're going to get this string, and we're going to force it, and we're going to make it an integer, right? Now, what's going to happen when we run this? Are we going to get an error?
8.
Is it going to work? Or are we going to get 8? Boom! We got 8. And why is that? Because it got this string, and it grabbed it, and it tried to convert it into an integer, and it did it. Hooray. But what happens if we did this? 3a. What happens if there's a string, and it looks like a number first, right? It looked like a 3, and it grabbed it, and it turned into a 3. But now we have 3a. What is a, really, when you turn it into an integer?
I think it'll probably give like an error or just 3.
Let's try that out. Oh, error, right? So whenever you're doing these type conversions, it's not like automatic and it's always going to work, right? You have to make sure that what you're giving the system has to make sense to the system. So when you gave it that just the string of 3, it says, I know this is a string, but I know this is also a number, right? And it's going to be able to get that number and turn it into an integer, right? But when you have the string, and it says 3a, 3a is not the same as 3, right? And it's going to say, I know the 3, but there's an a there. I can't really decide, like I can't really say that this is a number because there's an a. And therefore, I'm just going to back out and say this is not it. I can't do this, right? So when we have the 3, again, this will work with an 8. Or like 8. Let's go with 8a. CSE 8a, right? If we try to do that, run the Python, we're going to say, oof, 8a. There's an a there. I don't know what that is. So I'm not going to be able to turn it into something else. But let's do something like this. We can also type floats into strings. A string, so this 5 is what type is this 5 so far inside here?
Integer.
That's an integer. But with this type conversion, right, we're going to say, I want to get whatever's inside here, this 5 in this case, this integer of 5, and I'm going to grab it, I'm going to convert it into something else. And I'm going to try and make it into a string, right? So what's going to get printed out here when I run math operations?
Should be 85.
85! Why is that? Why are we getting 85?
It just like adds the strings together.
It adds the strings together, right? So it gets the string of 8, and then it gets the string of 5, and it grabs them and just puts them together.
Yeah.
Doesn't matter that they're numbers, really. Doesn't matter any of that stuff. So like if we have an 8 here, what's going to get printed out now?
8, 8, 5.
885. Right. All right, we are now at time, but basically, these type conversions is when we can grab stuff and turn it into something else, right? We can grab almost anything. I always say like absolutely everything. We can grab almost anything and make it into a string, because these numbers could be some sort of string, right? Because string are text. Because text you could write letters and you could write numbers, right? But when you're working with math operations like integers and floats and stuff, letters are there are very few letters actually used in math. And math is mainly just numbers. So when we had that A, it says, whoa, I don't know what that is, so I can't turn this string into an integer or string into a float, right? But you can turn you can turn certain things into other things. So like this int, so 3.14, it was a float, and you're gonna say, I'm gonna get this float and I'm gonna turn it into an integer. You can't do that, because there's still numbers. And it's gonna turn it into an integer, and it's gonna drop whatever was at the end. 3.14, I'm just gonna make it into a 3. Or a 42 float. 42 is different from 42.0, right? Because they're different types.